All right, so we're doing the last day of our spiral review, which is our review for our test next week. So by the end of the day, you should have all of this filled in and all of it ready to submit back if we need a copy of it. We're going to start up here with chemical formulas. So as we do this, we're going to fill in different things. So let's look at chemical formulas. If I am looking at my symbol, how many capital letters should I have? One. I should have one capital letter, right? All right. If I have a chemical formula, how many capital letters would there be? Okay. So for my formula, I could have 2 or more. What about if I'm talking about an element? One capital letter. What about a compound? 2 or more capitals. All right, so let's look through here. H2O, is that a symbol or a formula? Formula, right?
Yes.
Okay. 4O3, what is that?
Formula.
It's a formula, isn't it?
Yes.
Okay. CaCO3, formula. He, Ag, 2CO, formula. All right, now we got to check, is it an element or a compound? H2O, what is that? How do you know that? Two capitals. Okay, next one, element or compound? Elements. Because there's how many capitals? One. Next one? Compound. Next one? Next one? And the last one? Compound. All right. So now we're going to look at the column that says number of elements. In order to determine the number of elements, what do I have to count? All right. So I'm going to count capitals. All right. Atoms, what do I count? Well, I'm going to count each one of them, right? Okay, so I'm going to count each atom and add them together. So I'm writing that down. Count each atom and add together. And then for molecules, where do I look for molecules? Is that coefficient? Where's my coefficient? Number in front. Okay? So it's the number in the front to see how many I have. So let's come back here. H2O, how many elements are there? How many capital letters do I have? 2. On the next one, 4O3.
1.
The next one, 3. Next one,
1.
next,
1.
and then the last one, 2. All right, the number of each. So how many hydrogen do I have in H2O?
2.
How many oxygen?
3.
1 gives me a total of what?
3.
3. On the next one, what do I do if there's a big number out front? Multiply it through to everything that follows it, okay? So what does that give me? 12 total, right? Next one, how many CAs?
1.
How many C's?
1.
How many O's?
3.
Gives me 5. Come on, a little bit more lively. Let's go, people. Next one, how many atoms?
1.
Ag,
1.
and then 2CO.
4.
How many C's do I have?
2.
Plus how many O's?
2.
Gives me
4.
4. All right. Now for molecules, I'm looking at the number in front. What if there isn't a number? It's just automatically 1. So on my first one, how many molecules do I have? 1. Go to my next one. How many do I have?
4.
4 molecules of them. Good. Next one?
1.
He,
1.
Ag,
1.
and the last one.
2.
Good. All right. The next step, what we're going to do is we're going to figure out the formula for the compound or the molecule. All right, so as I'm looking at it, I'm looking at number 1 right here. Looking at number 1 here, I'm going to start with C. How many carbon do I have? 2. So it's C with the subscript of 2. What's connected to it? How many hydrogen are there? 1, 2, 3, 4, 5, 6. So what's my subscript going to be? Good. All right, go to the next one. Now, why is that not 2 molecules?
Because they're connected.
Because they're connected. See, it's touching right there, so it's all connected. All right, go to the next one. Now, this one's a little harder to read. That big one is a P. How many do I have of that?
1.
Do I need to put a subscript?
No.
No. And then I have 3 little ones that are Cl. So what's that make? Subscript of 3. Good. And then my last one here, looking at it. What would my formula be for it? Okay, so you said Cl. Do I put any number? Okay. Ooh, I don't know why I put a comma. I'm so sorry. Let's go C. How many H's? 3. And Cl, how many? Do I need to put a number? No. I don't know what I was thinking up here. I'm so sorry. All right. And the last part that we're going to be tested on next week has to do with chemical reactions. And we just finished chemical reactions. All right. There are 4 indicators of a chemical reaction. What's one of them? 4 signs that it's going to happen.
Change of color.
Okay. So color change. What's another one?
Gas
Temperature
formation.
change.
Temperature change.
Production of gas.
Okay. So gas or bubbles.
Solid.
And then
And,
production of
ooh,
a solid
what-
precipitant.
And then solid formation, and we call that a precipitant. Okay, precipitant. All right, so then I'm just going to kind of read through these, and we're going to put 1, 2, or 3 next to it. All right. Apple turns brown after reacting with oxygen in the air. What is it?
1.
Why?
Because it changed color.
Change color. Okay. Mixing vinegar and baking soda causes bubbles. What number?
3.
Good. Mixing milk and vinegar making curds.
4.
Wood burning.
2.
Copper metal in the roof turns green after reacting with oxygen in the air.
1.
Bread dough rising from bubbles produced when yeast reacts with sugar.
3.
And then when sodium and chlorine makes table salt, it releases heat during a reaction. 2. Good. All right. So you're going to take this sheet, you're going to take it home, and you're going to study it. So put it in your notebook. Y'all are going to study it. What we're going to work on now is chemical formula or chemical equations. So I'm going to work a little bit with you on chemical equations today.